Hello, my name is กรกมลเผือกหอม My student ID 62303400003 I'm majoring in robotics and automation system engineering at เกษตรศาสตร์ศรีราชา campus.
Hello, my name is ชมพูนิกบุญรอด My student ID 62340340020. I'm majoring in Robotics and Automation System Engineering at เกษตรศาสตร์ศรีราชา campus.
This is final project present video about robot arm design.
For robot structure and machinery design. This is robot arm design of Group 3. We approve some part from previous design and we use the same motor in every axis. It is NEMA 14. It have the size 35 x 35 and have the length 28. And for this design, we use this design to calculate the required torque and to calculate force analysis. The first part is rough motor selection part. For the first table is part list. It shows about mass and length of each motor and each arm. And for second table is operating speed. For in each axis, we use different operating speed. For axis 1, we use 80 rpm. Axis 2, we use 65 rpm. Axis 3, we use 50 rpm. And axis 4 and axis 5, we use 100 rpm. And the last axis 6, we use 125 rpm. And we define Ti for calculate as 2 seconds. And about this part, load torque is load torque of 6 axis that calculate from value of table 1. And about motor selection by using value from SolidWorks to calculate. For joystick, for this joy we use angular velocity as 13.09 radians per second. And angular acceleration is 6.54 radians per second square. And we got torque acceleration as 0.0016 and load torque we got 0.0018. And we use factor of safety as 1.5 and the required torque for this motor 6 is 0.0051 Newton meter or 0.51 Newton centimeter. And for this part we use operating speed as 125 rpm. So we select the NEMA 8 because NEMA X has enough torque for work with joy 6. For this motor, NEMA X has the torque as 1.6 Newton centimeter, so it's enough with the required torque that we need. And next joy is joy 5. This joy has angular velocity as 10.47 radian per second and angular acceleration is 5.24 radian per second square. So we got the torque acceleration as 0.0165 and load torque is 0.4207 and the required torque 0.6558 Newton meter. And this joy we use operation speed 100 rpm. So the motor that we select is NEMA 23. This NEMA has torque 1.9 Newton meter and is enough with this required torque. And this is torque curve. The y axis is show about torque in Newton centimeter and x axis is show about the rpm and frequency. And joy 4. For this joy, it has angular velocity 10.47 radian per second and angular acceleration as 5.24 radian per second square. So is the angular velocity and angular acceleration is same as previous joy 5 because we use the same operation speed. And about acceleration torque is 0.0281 and load torque is 0.6410 and we got required torque 1.0037 Newton meter. And we use the same motor with previous joy NEMA 23. It have torque 1.9 Newton meter. So it's enough for this joy. And next is joy 3. For this joy, it have angular velocity as 5.24 radians per second and angular acceleration as 2.62 radian per second square. And we got torque acceleration as 0.1198 and torque load is 0.4774 and same factor of safety 1.5 and we got required torque 2.1999 Newton meter. 25 but not the same with joy 5 and joy 4. Joy 5 and joy 4 is NEMA 23 but it has torque just 1.9 Newton meter but this is have 3 Newton meter, so it's enough to joy 3 more than previous one. And the joy 2 we got the angular velocity 6.81 radians per second and angular acceleration 3.4 radians per second square, and this joy we got acceleration torque 0.4072 and load torque is 3.8532 and 1.5 of factor of safety, and we got required torque as 6.3906 Newton meter, and we use NEMA 34. This NEMA has a torque 7.2, so we select this motor because it have torque enough more than the required torque that we got. And the last joy is joy 1. The angular velocity is 8.38 radian per square and angular acceleration is 4.19 radians per second square. So we got the required torque as 0.6108 and acceleration torque is 0.4072 and load torque for this joy is 0. Because distance of gravity force is parallel to axis 1, and we got load torque for this joy 1 is 0. And the motor that we select for this joy is NEMA 17. It has a torque equal 65 Newton centimeter, so it's enough with the required torque that we need. And this joy is used operation speed of 80 rpm.
This is all of part in the robot arms. This is the part list of the first simulation robot arm. For the motor, create new material for make the motor. For the arm, choose the nylon 101 and the arm 6 is payload. The material is titanium. This is the export view image of the robot arm. After calculate the required torque to select the motor that has appropriate torque. Some parts are in appropriate size. It's bigger than the arm and other parts. For this robot, hand developed by change the design, use the timing belt to apply the torque. For this motor 1 in acid 1 is appropriate for this design. The motor 1 has 0.65 Nm. That's enough for the required torque of 0.6108 Nm and has an appropriate size for this design. For this motor 2 in acid 2 is inappropriate for this design. The motor 2 has 7.2 Nm. That's enough for the required torque of 6.3906 Nm, but has an inappropriate size because it's bigger than the design. In this case, to develop the design, can use the timing belt to apply the torque and decrease the size of the motor. For this motor 3 in acid 3 is inappropriate for this design. The motor 3 has 3 Nm. That's enough for the required torque of 2.199 Nm, but has an inappropriate size because it's big. In this case, can use the timing belt to apply the torque and decrease the size of the motor. For about the motor 5 in acid 5 is inappropriate for this design. The motor 5 has 1.9 Nm. That's enough for the required torque of 0.6558 Nm, but has an inappropriate size. Is big. Can use the timing belt to apply the torque and decrease the size of the motor. For this motor 6 in acid 6 is appropriate for this design. The motor 6 has 0.016 Nm. That is enough for the required torque of 0.0051 Nm. Has an appropriate size. In table 4, it is fault analysis. Rotation about the acid 1. Only the one motor rotates. Motor 1 is Y acid. Motor 2 and motor 3 is X acid. Motor 4 is Z acid. Motor 5 is X acid. Motor 6 is Z acid. We use FA and FR for select the bearing. FA come from the force in acid direction that motor use. FR from the square root of Fx power 2 multiplied with Fy power 2. The table 6 is the conclude of the bearing select. The table says that motor 1 use the NEMA 17 motor with the frame size 42 and 42. Have the shaft
And that's all of Final Project Robot Arm Design. Thank you for watching.